Okay, let's look at some haplotype phasing. So gonna do typical UGENE maneuver here. Start out just the same way. I'm gonna save the alignment as cluster W format. I'm going to align this with MAFT. Forgive me these the display scaling for my computer is a little funky. Okay, it's done. The next thing I'm going to do is remove columns of gaps. You can just do Shift Delete, but I'll show you where the menu is there. I want to remove 90% there, so any of these columns that where 90% of it is just empty space, we're just going to get rid of them. And while this is grayed out, it's doing whatever it's doing in the background. It's quite annoyingly long sometimes, but take a moment to meditate. All right. Hopefully you've achieved some sort of spiritual harmony here. So let's look at the sequence. As you can see down here, there is a whole lot of stuff going on. And sure enough, as we slide through these different little blips in the alignment, we see polymorphisms galore. So this is indicating to me that there's probably some haplotype variation. And indeed, if we go to one of these spots, we can scroll down and we can see there's a breakpoint there where there's a significant difference. And with older sequences, this might, you might see something like this when there's a mix of forward and reverse reads. But in this case, we know that reads are all in the same direction. And if it was a mix of forward and reverse reads, it would be totally messy here. So it looks like MAF did a pretty good job of phasing these out into two chunks. Normally that's not the case. So I'm pretty impressed there. If, I think there might be a few here where it's not looking very good. So let's see if we can do it a different way. One way that is good is to do muscle. And so I'll just select some nucleotides and get a good bit of diversity on either end of the region that you want to align. And we're going to go into muscle. And the reason why we're using muscle is only because it has this option here, do not rearrange sequences. And we want to unclick that. We want to rearrange the sequences, and we're selecting just this column range that we selected there. So we're just going to align the sequences based on the content of those columns. And so it looks like it's finished. And now we see that, these are a lot more homogeneous. And it looks like it's phasing out into two distinct haplotypes just based on this region. We're going to see what happens if we go further. So I'm going to break up these two chunks of sequences, and the way I'm going to do that is notice I selected the top one. I'm going to hold the Shift button and I'm going to click there, and that selects that top chunk, and then I'm going to right click, and what am I going to do? I'm going to do export and move selected rows to another alignment, create new alignment. And what I'm going to do is I'm going to just name this Hap A. That's going to take them away and move them to a new alignment. And then this one, this is going to be our haplotype B. We can still see there's a little bit of stuff going on here. It looks like just a couple columns of gaps, and then we've got just a little bit of background polymorphism happening. So, there's probably more than 2 haplotypes. Let's take a look at what remains and see how this looks. So it looks like this remaining haplotype is pretty clean. Let's go ahead and just remove the columns of gaps again. And indeed, it's pretty clean. It's just a couple little blips. This one is, 10% A's. We're not going to worry about that. We could probably leave these as is. Or, if we really wanted to split hairs, we could pull out whatever this other haplotype is. So just for the sake of demonstrative purposes, maybe I'll see if we can do that. So again, I'm selecting the consensus up here, and then I'm going to go ahead and sort it out by all these columns here using muscle. And again, do not rearrange the sequences. You want to uncheck that. You want to rearrange them. Looks like it did some rearrangement, and we have this other chunk happening down here. And so we can do the same thing. We can pull this out. Again, we're going to right-click, export. Oh, that's not what I want to do. That's okay. Create new alignment. And Hap C. Really, I should have named this one Hap B, and this should be Hap A, whatever. Okay, so here's our haplotype C. Even within that, there's a little background noise, but we'll just take it. Let's see what we have left here. Yeah, other than those columns of gaps, there's still a little bit of stuff happening there, but again, it's more or less now separated to relatively clean haplotype variants. Now what you want to do is we'll grab a consensus. So how do I do that again? I right-click anywhere, and I go to copy paste, and I go to copy consensus. And then I'm going to go and just click anywhere here and paste it. Clipboard 51. Now I'm sure there's a way to rename it, but I haven't figured that out yet. So we're just going to have to remember what the name is. This is 51. We're going to export sequences alignment. Cool. So now we have what I guess we would call haplotype B, since I foolishly named this one A, is on the top here. I'm going to go in here and I'm going to copy the consensus. And I'm going to go into this and paste it. So clipboard 52 is haplotype B. Wonder if I can I rename it? Add sequence name. Yeah. That makes my life infinitely easier. That's hap. Okay. Oh, now I'm confused. Let's just start over again. talking and doing this at the same time, always fun. I'll just start with A and we'll make that real easy. Okay, now we'll do this one, which is our haplotype B. Remember, don't do consensus with gaps. We don't want the gaps. And we'll do hap C as well. Cool, so now we got all of our different haplotypes. We can align them with mapped. And then we can kind of see the variation between them. And we can also get our main consensus sequence. So, in some of them, they've got gaps. Some of them have different nucleotides. It's pretty polymorphic. It's kind of cool. So for our main consensus sequence, we will go and we will copy this consensus. And so we're going to have to replace the ends with the requisite nucleotide. So we can just paste it in here. And then what we can do is we can highlight that N and edit, replace selected character, and we can replace it with a G. And we can do that anywhere there's an N. I'm looking in the wrong place. Here's one. And so basically I'm making the longest length here. So anytime there's a space, I'm filling it with whatever nucleotide exists in at least one of the haplotypes. Because there's no way of communicating that it's either a space or a nucleotide. And so now I've got my consensus, so now I can go into iNaturalist, which goodness, I'm lost. There it is. I can go on iNaturalist, and here's what I'm going to do. Hint, hint, I already did it. So for the DNA barcode ITS, that's where you would put your consensus sequence. And then you'd also add that to MycoMap. You would go to the dashboard. Rather, you'd go to the sequence page here, and you would go to Edit, and you would replace whatever sequence is in there with your consensus, and then you would go ahead and you would do a new blast search. And probably 100. Whenever you're doing really polymorphic sequences, it helps to have more results because it'll probably match against a wider berth of things. So the more matches you have, the further down you can see things that match. So you'll do that, and then you're going to add just in iNaturalist your haplotype A, and you'll go to mycoblast search, and you'll add a new blast, and you'll make the custom title the iNaturalist number. You can just say Hap A. And you'll go into UGENE, and you'll get your Hap A, and you'll just copy. And you can do Control-C for that. Just regular old copy. And then you'll go and you'll paste it in here. And you'll put whatever results, and you'll save it. And after you save it, you get a URL, just like the one I just clicked on here. And you'll put that under haplotype A DNA barcode ITS. That way you have a link to that, you've got the sequencer haplotype A, and you just rinse and repeat. Create a new blast search, do haplotype B. Create a new blast search, do haplotype C. And add the blasts. It's really that simple. Sometimes it's not. As I mentioned, this one isn't perfectly clean. Some of these haplotypes still have a little bit of wonkiness happening in there. Did I really need to phase out haplotype C? Debatable. How different is it from all the other ones? Well, here's haplotype C. It very much resembles haplotype A. Pretty much across the board. So it's probably not necessary. Here's something that I didn't notice before, but it's actually here's an issue. So when I originally did this, I used a different program called Genius. So what's happening here is you don't actually have. This is wrong. This consensus is actually wrong. Go away. Really what happened here is you have something missing relative to one of the other sequences. So looks like it's this T is extra in haplotype B. It's missing from haplotype A and haplotype C. So the actual consensus wouldn't be Y, Y, T, K, G, K, K, K. This would be moved over. And your consensus sequence would just have 5 T's in it. It would be 5 T's and then C, T, T, G, G, T, G. So it would look like this one. But because these two haplotypes are actually missing that, it shifts the whole sequence over, right? You can see that, can't you? See? Everything's shifted over. So good thing I noticed that, and none of that's actually on the iNaturalist observation, but that's something to be keenly aware of. And let's look at that in the multiple alignment. And here's a way we can do that. Let's just, I'll start from here and I'll select over there and I'll see what that looks like in the big alignment. Oop, right here. Search for it, and it's going to take us right there. And so this is the region where things are funky. And so if we, oh, that's right. Our main alignment is just one of the haplotypes. Let's make a fresh export. Align it. Hopefully you can tell I don't use UGENE quite that much. but it is really good considering it's free. Okay, so here's what I wanted to illustrate. Here's that region that came out as a bunch of gibberish in the consensus sequence. Here's where we can see, you have a whole bunch that only have 5 T's here, and then we've got a bunch of 6 T's. And that shifts the whole alignment over. So here's the one with 6 T's. And actually, the one that has 6 T's over here has 5 T's here, and the one that has 5 T's here. Oops, sorry. Yeah, anyway, you know what I'm trying to say. Words are hard. It's going to be one shitty video. Sorry, guys. Hopefully that explains haplotype phasing and some of the pitfalls that you may encounter when you're doing it, and things to be aware of to look out for these kind of overall shifts that can make a weird consensus. Okay, that's all.